After watching the scenes from the World Cup of the crowds going into and out of the stadiums, I was struck by the similarity between the flow of people and that of water meandering downstream. Now that got me thinking, can you simulate the movement of people with SolidWorks Flow Simulation? To keep things simple, I built a small flat section of stadium seating, with some stairs where the people from upper level would join the lower level, a couple of concession stands, trash cans, and 3 exits. Setting up the problem is easy with SolidWorks Flow Simulation. The only tricky bit is to choose blood instead of water as our fluid, because people move in a clumpy way, which is better modelled by a non-Newtonian fluid such as blood. When we switch to a flow simulation that has already been set up, we can see our biggest assumption. In this simulation, each seat has its own flow inlet, which basically means we have an infinite human flow from every seat. Now, this means our flow simulation is going to give us crowd behaviours rather than absolute numbers. But in the early stages of product design, understanding your design's behaviour is very valuable indeed. The first results we want to look at is the velocity map of our crowd. But we need to interpret this slightly differently than normal. We can see how our infinite human flow moves around the obstacles in the stadium. But we need to interpret the red areas in these results to show areas of high footfall traffic, rather than areas where the crowd will move faster. In the real world, when we get a greater packing of people together near the exits, the flow actually slows down. The exits begin to choke. So red isn't necessarily a good thing. From these results, it is obvious that there are a lot of people moving towards the right-hand exit, suggesting that we should either add an extra exit or move the concession stand and trash cans to a different location, reducing the extent of the red region and as a consequence ease the flow towards the exit. Looking at flow streamlines is a great visual aid to understanding a flow field. By selecting the stadium exits, you can see where the majority of the flow, or in our case people, are coming from. In this study, most of the flow is coming from the upper level stairs and the rear of each section of seats. Once again, this result suggests that the flow needs to be balanced by alternative exits, allowing the people at the front of the seats to move in an orderly fashion towards the exits. I hope this demonstration has shown you that flow simulation isn't just about measuring pressure drops, forces or velocities. It's an engineering design tool that helps you see the world and your products in a new light. Contact your local SolidWorks reseller or explore this website further to learn more about SolidWorks Flow Simulation.